Speaking about coming to the dark side. They have misfortune cookies, and you do, and you do too.
Thank you. Without further ado,
it takes a lot to make a stew.
A pinch of salt and laughter too.
A scoop of kids to add the spice.
A dash of love to make it nice. And you've got
too many cooks,
too many cooks,
too many cooks, too many cooks,
too many cooks,
too many cooks, too many cooks.
It takes a lot to make a stew.
When it comes to me and you,
And him and her and the baby too. Too many cooks, it's true.
they say it goes, it'll spoil the broth.
Honey, I think that's not true.
Well, maybe too many cooks will spoil the broth, but they'll fill our hearts with so much love. Too many cooks. A family is like a soup.
Everyone adds an extra scoop.
Mix an ounce of smile so sweet.
A dash of cool to add the heat. And you've got
Too many cooks.
too many cooks.
Too many cooks.
all right. Well, so if you have no idea what you just saw, Too Many Cooks is a TV skit that went viral a couple months ago, and we liked it. And I'm sorry. So you should watch it, and if you've seen it, then you can enjoy some references throughout this presentation. And if you haven't, you could just try to laugh at the funny pictures. Right, so who we are. We're the Malware and Vulnerability Research Group at Checkpoint. Checkpoint has this tagline that we secure the future, and we actually try to do that by finding problems, telling the vendors about it, and sharing them with the community, which is you guys. So let's talk about what's in store for today. So we're going to be very quickly going through what TR69 is. We're going to explain a little of what we talked about last DEF CON, which will lead us to the motivation behind the research that we're presenting today. We'll talk about the TR69 census 2014, give you some interesting bits of our research story, and then some technical details. We'll follow to show what can only be described as mass bonage, and conclude talking about why this won't go away so quickly. So TR69, TR is like an RFC, right? So TR stands for Technical Report, number 69. And this defines the CPE WAN Management Protocol. CPE is Consumer Premises Equipment. And this is also called just CWMP or plain TR69. And this was released in 2004 by the Broadband Forum, which is a group of companies working to define broadband standards. And there were a few amendments so far, but remember that this was released exactly 10 years ago. And this is what ISPs use to provision your devices. This is also called zero-touch configuration. They use it to monitor your devices for faults or malicious activity, and configure anything they want in your home routers, including getting the MAC addresses and host names for anything on your network, creating additional Wi-Fi networks, and go as far as deploying new firmware. So this is how TR69 sessions, or provisioning sessions, look like. So on the right side, you have the CPE, right, which is the TR69 client. That would be your home router. And on the left side, we have the TR69 server, which is called an ACS, an Auto Configuration Server. And they talk in basic SOAP RPC, which is XML over HTTP. And it's important to mention that the client always initiates the connection, which is a single TCP connection over which RPCs are called back and forth. So the client begins with an inform, telling the server why this session was initiated. Then the ACS follows with provisioning functions such as get parameter values and set parameter values, which do exactly that. So there is a dual authentication mechanism, and the CPE should make sure that it's talking with a verified ACS, and the ACS should only accept sessions from authenticated CPEs. Now, there's also a thing called a connection request, and we'll talk about that. So our findings so far, we presented this at DEF CON. So our research uncovered implementation and configuration flaws in many ISPs' ACS deployments. That would be the TR69 servers. We found that ACSs are a single point of ponage in modern ISP infrastructure. We found many TR69 implementations that just aren't serious enough, and that leads to ISP fleet takeover. Right. So you remember that connection request? So this is straight from the TR69 specification. The ACS can at any time request that the CPE initiate a connection to the ACS using the connection request notification mechanism. Support for this mechanism is required in a CPE. So in fact, every TR69 client in the world is also a connection request server. And on which port, you ask? So it turns out IANA assigned 7547 for all TR69 uses, including that connection request port. And this is a widely used default. So now let's look at some very interesting research released last year from the ZMAP guys, which is Zachary Derumerich and his friends from University of Michigan. And they actually scanned 2 million random addresses on every port up to 10,000. And they found that CWMP, or the TR69 default port, is in fact the second most popular open port in the world, right after HTTP, right after port 80, with 1.12% of the internet address space at all, is listening on the WAN with this protocol. So remember, this is for a protocol that was invented 10 years ago. This is, it's not as old as HTTP, so gotta say something. So how many devices are 1.12% of IPv4? It's actually around 45 million devices listening on 7547. So from a vulnerability research perspective, no matter how hard we looked, no one is talking about this service. And there has to be something there. Right. So let's review the top 2 open ports in the world. And previous research has given us this image. So there are around 70 million devices, about 50% of which are web servers, like just regular web servers with Apache leading the bunch. You got your Nginx's, IIS, and then a small percentage for the rest, including Lightspeed and Google dedicated servers. So the other 50% or so are simply Internet of Things devices. Most of them, most of them are routers, but you got your webcams, your VoIP phones, and of course, let us not forget about the IPv4 enabled toasters out there. So, by the way, people start understanding that leaving these things open to the WAN is dangerous. And luckily, we're seeing more and more devices updated to have port 80 access blocked on the WAN by default. So now remember that not only there is a diversity in the server software, it's also being used for different uses. So serving websites, also to cloud services, management interfaces for each devices. So it's kind of a messy landscape. But now, moving over to 7547, we have around 45 million devices, and these are all Internet of Things devices. And all of them are listening on their connection request port with that simple service. There's nothing else there. So this landscape is much clearer. And remember, we're looking for security issues here, so we're looking to find significant numbers affected. So as a first step, we needed to stop guessing and estimating, and we conducted the TR69 census 2014. So we scanned 7547 on the entire IPv4 address space. And this was done last month, a few times actually, with the gracious help of good friends at Rapid7 and University of Michigan, who contributed to this research. So thanks a lot, guys. And the results are 1.18% of the public internet responds on 7547. So we actually communicated with 46,093,733 devices, who answered our benign requests for get slash. Now, these are all over the world. It's not just like one country who accidentally left the port open. It's 189 countries, which makes sense when you remember that it's a protocol requirement to leave this port open for the ACS. By the way, note that 0.06% increase from last year, and that's actually 2.2 million devices added in a year. And that's showing us that numbers are still on the rise. So we're set on finding an issue with TR69 client-side implementations. And the natural thing to do at this point is look at what implementations we're seeing out there. So we categorize the responses and sum up the numbers, and we get this. So we have five main connection request servers out there, but it's very clear that there's this thing called ROM pager that's leading the pack, right? And I think that means that we got ourselves a target. So what is ROM pager? It's an embedded HTTP server. It was released by Allegro Software, which is a Massachusetts-based company. It was optimized for minimal environments, small binary, small memory requirements. It was introduced in 1996. And there's been many versions out since. The current version is actually 5.4. So it's a natural next step. Once we decided that we're going after ROM pager, we need to see what versions are out there. And this will help us focus our efforts. And we run the short script again, and so you'd expect sort of a normal distribution out there for these versions in the wild. We actually see only 4 versions, 4 different ROM pager versions out there, and instead of a normal distribution, we get this. So yeah, so 98.04% of identified devices are actually version 4.07. And that's a pretty old version, too. So this is where we grew suspicious. And, I mean, what can explain this incredible popularity of a single version? So, could it be a batch of old devices at a single ISP or something? We just don't know yet. And this really piques our interest. So, we have to find this out. So we went ahead and we bought a new, a TP-Link router, and we unbox it, we plug it in, we connect it to our network, and it's running ROM pager 407. So, we thought maybe this is an old version of the device, it has like an old version of ROM pager. So we downloaded the latest firmware from the TP-Link website, and we flash it, we reboot it, and it's still ROM pager 407. Yeah, so at this point, we can start understanding the popularity of the 407 version. So I mean, we have no idea why it's there, but if it's somehow embedded into brand new devices off the shelf with the most recent firmware, then that could certainly explain why we're seeing so many of them. So let's just try something here. Does anyone in the audience happen to have an unopened brand new router? Let's see. Anyone? Yes. Oh, thank you. Oh, wow. Thanks so much. I don't know you at all. You don't sit next to me. Thanks so much. We're going to do something with this in just a short while. What a coincidence. So, we dive into this ROM pager 407, and this was released 2002. And it seems to run on a whole bunch of devices. So, so we return to our scan data and start counting. So we actually have 2,249,187 devices listening on port 80 with ROM pager 407. But 11,328,029 devices on port 7547. And, suddenly we're like, I mean, wait, there are 12 million devices out there with this very specific version of a web server that was released in 2002, listening on the WAN. I mean, yes, this is a perfect vulnerability research candidate, right? So zooming out for a moment, this is, to the best of our knowledge, the most popular specific version of any network application service that's currently available online on the public internet. This specific version is deployed on 200 different devices from 50 different brands, and we're going to do whatever it takes to pwn Rompager 407. Handing it over to Lior.
Hi. I'll walk you through the process of how I analyze the firmware and some very interesting results I found on the way. So let's start it. So at the beginning, I only have the firmware file itself, which was downloaded from the vendor website. In our case, it was TP-Link. On first glance, the firmware is looking like a big blob of compressed data. But as any rookie firmware analyst know, the first thing you need to do with a firmware is to binwalk it. So binwalk is this great tool developed by DevTDYS0, which recognized and unpacks many common firmware files. Luckily, binwalk easily recognized and extracted 4 files: a small bootloader, 2 images, which are the vendor logos, and of course, the main uncompressed firmware file. After I got the first firmware, I decided to download some more firmware which contained Rompager 407. So I downloaded some more, and some more, and some more, and all of them had the same XenOS header. And also, they had the same architecture, which is MIPS. So why all these Rompager 407 firmwares look so similar? At this point, I have absolutely no idea why. So one might ask itself, what is this XenOS we are seeing in all the firmwares? So a quick lookup in Wikipedia revealed that XenOS is an embedded OS created by Zixel, which is a major Taiwanese DSL vendor. And XenOS is an RTOS, a real-time OS, which means it's a very basic operating system without any file system or permission mechanism. Just one big binary responsible for everything. When you Google up XenOS, you also see that XenOS is very notoriously known for ROM0 vulnerability, which was discovered last year. This vulnerability allows an attacker to gain the router credential by downloading the entire router configuration, including username and password, from an unprotected path. All it takes is for the web panel to be available at port 80 and to be open to the attacker. And the recent polls show that this vulnerability affects about 1.2 million devices. So before we actually start analyzing the firmware, let's see what our attack surface looks like. So in port 80, we're getting an unauthorized response, which asks us to insert the credentials. But since we don't know them, we're getting this instead. In port 7547, we're getting object not found for any path except for the correct connection request path. For now, we assume that we do not know the correct path. Before I actually start diving into the code, I did some basic fuzzing over the HTTP headers. Suddenly, I managed to crash the router. This is how I discovered the first vulnerability, overflowing the digest username header. So to understand why this is happening, let's explore some Rompager code. What you see here is a function responsible for initializing the HTTP handler structure. For each entry consists of HTTP header name and the relevant handler function to pass this header. This is the function which handles the parsing of the digest username header. Can you see what caused the crash? An unprotected strcpy. This explains why we were able to overflow the username field. But what actually caused the router to crash? Because we have no symbol and no dynamic analysis capabilities, it's very difficult to know. So, no dynamic analysis capability, maybe my model supports JTAG. For those of you who aren't familiar with JTAG, it's this interface designed to do hardware verification and debugging for embedded devices. So I opened up the router, but I couldn't find any JTAG connection. What I did find was something that looked like a serial port, a UART port, So I gave it a try and soldered some connector to my router. And using Bus Pirate, which is a serial to USB interface, I connected the board to my computer. Now, when I boot up the router, I could see some debugging info, which is very cool. But what happened if I try to crash the router now? This is what I got. A very nice-looking crash dump with registers and stack dump. You can see here that the EPC, which is the MIPS instruction pointer, has been overwritten with my input. This means we're in control over the instruction pointer. Some further analysis of the crash dump allow me to fully understand the vulnerability. The strcpy caused us to override the function pointer, which conveniently lays 584 hexabyte after the username. So exploiting this is pretty simple, right? Just send a large username, you override the function pointer to point to your shellcode, and you have a remote code execution. Sounds way too easy. Any problems? So yeah, there is a slight problem. Although all the vulnerable firmware are XenOS based, each one looks a bit different regarding memory layout, and it even changes between different firmware versions of the same model. This means that we cannot know the correct position of our shellcode in memory, and therefore we don't know with which value we need to override the function pointer. Of course, if you know the exact memory layout of your victim, you can run code on his router without any problem. It's also important to notice that an attacker only gets one chance per router, because crashing the router will eventually cause it to change its one IP address due to dynamic memory IP allocation. A potential solution for this whole problem is to find some info-leak vulnerability that would disclose the memory layout. This could work, but for now on, let's keep looking for something else. So because I had no way of debugging, I had to use some primitive debugging capabilities that were built into the bootloader through the serial port, which allowed me to patch the firmware before it was being loaded. It was handy, but very tedious process. And after way too many hard resets, I found out that there are hidden telnet commands in XenOS, which let you patch the router memory online. This led to the creation of Zordon, which is a remote XenOS debugger built around these telnet commands. With Zordon, you can set breakpoint, view and edit memory, and read and write registers values. This made the dynamic analysis task way more convenient. So using my brand new debugger, I was able to understand much better the nuts and bolts of ROM-Pager, which eventually led me to the second vulnerability. You see, ROM-Pager has no dynamic memory allocation capabilities, so each request is handled in a pre-allocated structure, with up to 3 requests can be handled at the same time. You can, by sending 3 consecutive requests, you can override the HTTP handler structure, which we saw earlier, which again allows you to control the instruction pointer. Can it be exploited? Well, sort of. Theoretically, you can blindly read memory addresses by changing the pointer of some HTTP header name. But at this end, I decided to leave this vulnerability because it will only work on port 80, and we already have ROM 0 for that. So moving on to the third vulnerability. So yeah, ROM-Pager support cookies. Because ROM-Pager, as you remember, does not have any dynamic memory allocation, it holds an internal cookies array for each request, which support up to 10 cookies with 40 byte long. Each one is up to 40 byte long. The cookies name are constant, C0, C1, C2, up to C9. And the client sending one of these cookies looks something like this. So let's take a look on the cookie handler to see how ROM-Pager actually stores the cookies. As you can see, first ROM-Pager checks to see if the first character of the cookie name is a capital C. If so, it will, if so, it will convert the rest of the cookie name into an integer, and will use this integer as an index for access the request cookies array. So if you can see here, the S3 register which is the integer, is multiplied by 40, and this will add, and later on they will add the result to the base of the cookie array, and will copy the cookie value to this position. So basically, this gives us an arbitrary memory right for a relative position in ROM-pager internal structure, which means we can pretty much control everything that ROM-pager does. A very nice bonus is the ability to overflow the 32-bit value to overwrite on a negative offset. So let's take a look on some non-harmful example. Instead of C0 or C1, we'll send this cookie with its index pointing exactly to the request path field. We can now set this path to anything we like. In this case, we'll get this. We've managed to override the path of the request to our value. This technique works for any model on any brand that we had legal access to. But this actually has far worse consequences. You see, with a few magic cookies added to your request, you can bypass any authentication and browse the configuration interface as admin from any port. So to prove this insane claim, we will see a demo in just a minute. And now handing back to Shachar.
So just before we see the demo, you know, we're not here to point any fingers or anything, but this popped up on the tech support forum. This is the official tech support forum for TP-Link. And, you know, this guy was asking them, you know, could TP-Link please clarify which, if any, models are vulnerable, whatever. There's just the report claims many Wi-Fi routers are affected, whatever. And then TP-Link answers this. And I'm not going to read it out, actually. I'm just going to highlight this one little. We confirm it cannot actually attack our modem router. With that, I'm going to continue to our demo. Right, 1 second. Right, we are ready. Hold on 1 sec. Are we seeing everything right now? Yes, we got it? Awesome. All right, so we're going to begin with the movie, and then we're going to really actually try to do this live. But let's first do the movie. So, here's a router. Right now we're accessing it through the LAN. We get the username, password. This also works from the WAN, so don't forget. Well, we can also try 7547, and we get the object not found. So now we turn to our Chrome extension. And we reload the page, and that's it. So, yeah, thank you. Right. So let's actually go ahead and try this live. Hopefully we'll be able to get it. All right, awesome. So we have this. You know, we can also try 7547, hopefully. Yeah, so we can either go with a 7547 or the normal one, but we're just going to activate the, hopefully, wait. Of course, something should fail. All right. Well, we haven't prayed enough to the demo gods today. But trust me, it does work, as you've seen in the movie. So I don't know exactly what happens this. Yeah, the Wi-Fi might be doing the... Oh, where? Yes. All right, so just making sure the video gets... This is a TP-Link device. All right. We're not going to do anything, so let's just resume legal mode here. You know what? We're going to take the chances. But we're going to wait. Let's just disable this. Hopefully the Wi-Fi should work. Yes, I'm using open. Sniff ahead. So if this search will work right now, yes it does. Very slowly though. Alright, so we're getting, what is this, 26 million devices on port 80, 6 million devices in 7547. So it's, I mean, Shodan doesn't scan everything, but these are pretty much vulnerable devices out there, and I will not click it because that will, yeah. No, I'm sorry. Sorry, not on camera, not on camera. Right. So let's see. Are you seeing this? Yes. Awesome. So this vulnerability affects devices in 189 countries all over the world. In some countries, this is incredibly popular, and it's affecting up to 50% of all the IP addresses in use in that country. That's not a mistake. It's just 1 out of every 2 IP addresses. And you can look at the website. We have all the info there. Yeah, that makes Marf very happy. So I know what you're thinking. I have to turn this off on my device right now. And as soon as you get home, you'll enter your configuration interface, and you'll find the CWMP settings and deactivate it. So you hit save, and then it doesn't do anything because 7547 is still open on the WAN. So that's right. There is no legitimate way for you to turn this off, even as admin. Some countermeasures. So yeah, the first one is some good advice. Then you can also use alternative firmware if you're a technical user, which most of you pretty much are, but a lot of people aren't. Bridge mode is actually a good advice. I mean, if you can switch your device over to bridge mode and then use something else to route your traffic at home, then you should be good. Don't buy these models until they're fixed. So let's understand the supply chain here. You know, AllegroSoft at one point provided ROM pager to a certain chipset vendor, right, which implemented the TR69 functionality and bundled this into their SDK as a bonus feature. Now, this SDK was provided to manufacturers who compiled their firmwares for each product series and model. And just to make it a bit more complicated, ISPs customize their firmware, to include brand logos, embed default configurations, and deploy these versions to consumer devices. So you can start to understand this complex behind-the-scenes chain, and think about what this means for security updates, because this makes the update propagation chain incredibly slow, if not non-existent. Because AllegroSoft has to provide a fixed version to the chipset vendor, which has to incorporate this into their SDK, which has to then be given to manufacturers who have to recompile firmwares for every product line and model, who have to give it out to ISPs, which have to recompile the updated version using their customizations. And now this thing has to be deployed on every device. This is a nightmare. In this case, we can truly say that too many cooks do spoil the broth. And, well, so this is the good case we're talking about here, because, when your device is controlled by the ISP. Because if you just bought your home router off the shelf, most people never upgrade their router firmware. So anyway, this vulnerability will be here for months and years to come. Let's talk about vendor communication. So we contacted AllegroSoft and the major affected vendors we provided a full description of vulnerability and non-harmful POC to trigger it. So despite some broken English, the message did get through, at least most of the time. We've already seen some patch firmware out. Allegrosoft, sent out a press release, and they're saying that they can't force any vendor to upgrade to the latest version. And you know what? They actually provided a patched version in 2005. So think about how broken the update chain is now. So by the way, they were not aware of the implications of the vulnerability. They just found it by themselves and fixed it. So this is a couple of frequently asked questions. So is RomPager bad? No. They're really actually very responsive, security aware. We just happened to research an old version of their software. I'm not saying it's any better or worse than comparable software in 2002. Is this an intentionally placed backdoor? It doesn't look like one. Then again, the best ones don't look like one. Yeah, can we share the exploit? I'm sorry, no. So people come up to me and they'll say, can tell me which IPs are affected in my country, and I'm saying, scan it for yourselves. There's something very important here to mention, that some ISPs actually, use custom TR69 connection request port. I know in Israel we use a very custom port that's not used anywhere else, and you get very different results when you add that port to your scan. So you have to, do the specific research for your country. A short recap. So we found a pretty serious vulnerability in the most popular service exposed in IPv4. At least as far as we know. Do come to us if you know anything else. And hey, industry, fix this. Thank you very much. Sorry? Oh, what? Okay, never mind. Yes, there are cookies if you haven't seen them yet, so you can have a cookie. Is there any question? Would like to take them? Yes, please. Have we tested on alternative firmwares like DDWT and Tomato? So we haven't tested them, but they actually released, statements that they don't have RomPager, so they're not vulnerable to this. Any alternative firmware that we know. So you're going to have to take your chances with whatever they have there. Yes, more questions, please. There's one very far. I have no idea if I'm going to be able to listen. Yeah. Could redirecting that port? All right, so I guess it depends on the actual device. I think it would not allow you to redirect the port because it needs to use it by design. But we haven't tried it. Yes, more questions, please. Thank you very much.